If you work with AI, then you definitely know that feeling, that frustration when a large language model just hallucinates an answer. Well, today, we're going to dive into a new architecture that's designed to solve that exact problem. It's called Agentic RAG. But let's start with a question. What if an AI could do more than just, well, answer a question? What if it could act like an autonomous researcher, reading, reasoning, using tools, and even checking its own work? Now, this isn't just some sci-fi concept. It's the fundamental promise behind a brand new approach to AI.
You see, as powerful as large language models are, they have this one critical weakness. They're basically disconnected from external, up-to-the-minute knowledge. And this is what causes them to hallucinate, to generate answers that sound totally plausible but are, completely made up. This is the core challenge that Agentic RAG is built to solve.
So how do we get there? In this explainer, we're going to start by looking at the limits of the current solution, which is standard RAG. Then, we'll take apart the new agentic architecture piece by piece. We'll watch its reasoning loop in action with a real example. And finally, we'll look ahead to the future that this new kind of autonomous AI is starting to build.
To really appreciate where we're going, we first have to understand where we are right now. The current industry standard is something called Retrieval-Augmented Generation, or just RAG for short. So let's quickly break down how it works. The traditional RAG pipeline, which you're seeing here, is a pretty straightforward linear process. It takes in a bunch of documents, chops them up into chunks, and turns those chunks into numerical embeddings that get stored in a vector database. When you ask a question, it finds the most relevant chunks and just feeds them to the LLM to generate an answer. Now, this does help ground the AI in facts, but this simple one-way flow is also its biggest weakness. And this right here really shows you the breaking point. Standard RAG is great for simple fact-based questions, where the answer can be found in a single piece of text. But the moment you ask it to do something complex, like, say, compare and contrast findings from multiple research papers, the simple retrieve-then-generate model just starts to fall apart. So here's the bottom line. Traditional RAG has zero ability to plan. It can't take a complex question and break it into smaller, manageable steps. It has a really hard time synthesizing information from different documents. And, maybe most importantly, it has no way to verify its own work, which means it can still hallucinate details that aren't even in the source material. So, these weaknesses, no planning, weak reasoning, no verification, they really demand a totally new way of thinking. And this is where the agentic architecture comes in. It fundamentally rethinks how an AI can approach a problem. So here, we're moving from a simple, straight line to a much more dynamic system. This is Agentic RAG. It's not a simple pipeline anymore. It's more like a sophisticated workflow engine for intelligence. It has specialized parts, a data pipeline, an agent core, a whole suite of tools, and a really critical verification loop. Let's break down each of these components. Okay, first up, the data pipeline. Now, this part is kind of similar to traditional RAG, but it's usually a lot more advanced. Its whole job is to take raw documents, like PDFs, parse them intelligently, and break them down into meaningful, semantically related chunks. Then it creates those vector embeddings for storage. Basically, it turns a mess of unstructured data into a structured knowledge base that the agents can actually work with. And right here is where we see the first huge change from the old model, the planner agent. When a complex question comes in, the planner's job is to be the strategist. It analyzes the problem, breaks it down, and creates a logical step-by-step plan for how to solve it. So if the planner is the strategist, you can think of the orchestrator agent as the project manager, or maybe the brain of the whole operation. It takes the plan from the planner and actually executes it step by step. It's the central controller deciding which tool to use, when to use it, and how to manage the whole flow of information until it gets a final answer. Now, the orchestrator doesn't work alone. It executes its plan using a whole suite of tools. And this is what gives the system its agency, the ability to do things, not just generate text. It can pull from its internal knowledge base, it can search the live web for new information, it can run Python code to do calculations, or even summarize super long documents. It can actually take action. And finally, we have what is maybe the most important piece of the puzzle, the verification loop. See, after an answer is generated, it doesn't just get sent back to you. It first goes to this internal critic. This system actually grades the answer for accuracy, checks it against the source documents, and scans for any hallucinations. If the answer fails, it triggers a retry, forcing the system to go back and rethink its approach. This loop is the real key to reliability. Okay, so we've got all the pieces on the board.
But how do they actually work together? Let's walk through a reasoning loop with a real-world example.
This diagram really shows you how dynamic this whole process is. Your question kicks things off, and the planner creates a plan. Then the orchestrator enters this iterative loop. It acts, it calls a tool, it gets some information, it generates a piece of the answer, and this is the critical part. It sends it for verification. If it passes the check, great. If not, the system is forced into a retry loop, making it rethink and refine its answer until it gets it right.
So let's make this concrete. Imagine you ask it to compare model accuracy in these research papers. First, the planner creates a multi-step plan. Then, the orchestrator gets to work. It calls the search tool to go find those papers. Then, it uses the retrieval tool to pull out only the result sections from each one. It might even call the Python interpreter to actually extract and compare the numerical values directly. Only then does it generate a summary. And for that final step, it verifies that every single claim in its summary is directly supported by the text in those papers.
This whole multi-step verified process, it's a huge paradigm shift. So let's talk for a minute about why this all matters and what it means for the future of AI.
The advantages here are pretty clear. You get true multi-step reasoning that can tackle complex problems. You dramatically cut down on hallucinations because every answer is constantly being checked against the source data. The AI gets what you could call tool-based intelligence, letting it perform real actions. And all of this together makes AI systems way more reliable, moving them from being these unpredictable novelties toward being truly robust engineered software. But of course, it's not a silver bullet. At least not yet. This agentic approach definitely has its trade-offs. All those extra loops and LLM calls mean more latency and higher costs. It's slower and more expensive. Designing these agent workflows is also a really complex engineering challenge in itself. And at the end of the day, the system is still only as good as the information it can find.
Now, looking ahead, this field is moving incredibly fast. The next big frontiers are all about making these systems even smarter. Things like using graph-based retrieval to understand complex relationships, adding multimodal understanding to process images and charts, and giving them long-term memory to learn from past conversations. The ultimate goal here is to create a truly self-improving agent that actually learns from its own experience.
And that really brings us to our final thought. What we're witnessing is a major transition. AI is evolving from being a simple tool that just answers our questions into an autonomous partner that can conduct its own research. So the real question we have to ask ourselves is, as these systems mature, what incredible new frontiers of science and knowledge will they help us unlock?